NCO brings high quality satellite data to the UK research community. We do lots of things here in Earth observation, but particularly we're very good at deriving really important data sets about the Earth, exploring the Earth if you like, and looking for change, particularly long-term change, whether it be from climate, human activities, agriculture, you name it, we do it.
For 25 years, I've worked in trying to understand the Earth's carbon cycle, in particular the land part of the carbon cycle. Climate change has been driven by carbon dioxide in the atmosphere, and so we're really deeply interested in what's happening as regards putting carbon dioxide into the atmosphere and taking carbon dioxide out of that. As part of that effort, we conceived the idea of the BIOMASS satellite, which is a satellite devoted to measuring the structure and the biomass and the height of forests, as well as some other things. And by getting that information to help to get a better handle on the role forests were playing in the global carbon cycle.
So for BIOMASS's incredible mission, what it will do for us scientifically, first of all, is really close a gap in our understanding of carbon cycle in those tropical forests, which we can't go there ourselves, we have to explore from space. So that's the first thing. But the second thing is, if we can really start to get those biomass measures accurate, we can look at both how much carbon is stored there, how much carbon change is occurring there. And that's potentially important for both climate policy, but also it's possible that the Amazon forests in particular could be an early warning of change in our whole climate system. So exactly how it's behaving will be an indicator for that future. So really important, and we hope the results will feed into the international climate negotiations.
The BIOMASS satellite is specifically designed to measure the key properties of the world's forests. If you use a long wavelength radar, you actually go right through the leaves. In fact, you can't see the leaves at all. And what you see is the wood. You see the branches and you see the trunk. And you can actually produce images of forests, but with the same instrument you can measure the height of the forests. With special, very clever orbits, you can make a 3D map of forest structure. Because it's an ESA mission, ESA tends to fund all the technology stuff, but NERC helped a lot in getting off the ground to help me to show the ionosphere wouldn't screw the mission up. We don't just build the instrument and do clever signal processing. I was doing NERC-funded work, which did a lot of work on modelling and statistics and measurement, which provided underpinning science for what we would do with this mission. NERC was in at the start, and it's been a part of the backbone of the mission. The really important thing is what happens next. So it's how the data are used. So my real feeling is that let's make sure these data are used properly by the planet to our benefit.